this is Kasturi De. Today I'm going to continue with the discussion of the carbon and its compounds, this question answer series. Okay, so few questions are still left, so I'll start with the discussion today. So first is state 4 physical properties of carbon dioxide. See, carbon dioxide is a fairly soluble gas in cold water, okay, but under pressure it dissolves rapidly in water. Okay, in cold water it rapidly dissolves under pressure. Okay, but in ordinary pressure it is fairly soluble. Then carbon dioxide is heavier than air. Its vapor density is 22. Okay, but that of the air is 14.4. Okay, 14.4 is air density, and that of carbon dioxide is, that's why it can be collected over air. Okay, then not over air, it's by and that means it is it can be separated from air very easily. Okay, it's not collected over air, it is collected the air remains above as it is lighter, and the density of carbon dioxide as it is heavier, it will remain at the bottom. Okay, by that way it can be separated. Then when carbon dioxide is at room temperature, that is around 20 degrees centigrade, and at a pressure of 70 times the atmospheric pressure, is suddenly allowed to expand through a nozzle, it will solidify into dry ice. See, when carbon dioxide is at room temperature, that is at 20 degrees centigrade, and the pressure of the atmospheric pressure is 70 times than the pressure of the carbon dioxide is 70 times than the atmospheric pressure. Okay, that means under high pressure and that room temperature, carbon dioxide, when it is allowed to pass through a nozzle and it is allowed to expand, this when the carbon dioxide was in pressure at 70 times heavier, 70 times more than the atmospheric pressure, and the outside temperature is 20 degrees centigrade. That time, if carbon dioxide is allowed to expand, okay, through a nozzle, it will solidify into dry ice. Okay, suddenly the pressure is released. Okay, the pressure was 70 times than atmospheric pressure, but suddenly the pressure is released and the room temperature, the temperature remains at 20 degrees centigrade. That time only carbon dioxide will expand into change into dry ice. Then carbon dioxide is a non-poisonous gas, but animals who inhale this carbon dioxide for a longer time, they can die due to the want of oxygen. Okay, then we come to draw a neat and fully labeled diagram for the preparation of carbon dioxide gas in the laboratory. Details of the procedure is not required. See, this is the laboratory preparation diagram. Wolf's bottle is taken, which has two mouths. From one mouth thistle funnel is attached, and through which dilute hydrochloric acid is dropped, and there are certain marble chips are kept inside that wolf's bottle. Okay, and through one mouth of the wolf's bottle, this delivery tube is inserted, with the other end of the delivery tube is inserted inside a gas jar. Okay, gas jar, and we will see that when the reactions, see, the dilute hydrochloric acid is being filled up till in such a way that the thistle funnel just tips, that this thistle funnel is just hydrochloric acid. Okay, it's not touching the marble chips also, the thistle funnel will not touch the marble chips. Okay, so the reaction will take place, and inside the gas jar there will be carbon dioxide being collected. Okay, This is the diagrammatic representation of the lab preparation of carbon dioxide. Then write chemical equations for the preparation of carbon dioxide. Calcium carbonate only. When calcium carbonate is heated, then calcium oxide and carbon dioxide is formed. Then sodium hydrogen carbonate only. Then when sodium hydrogen carbonate is heated, then sodium carbonate, water and carbon dioxide is formed. Then when sodium hydrogen carbonate and dilute acetic acid is reacted with it, okay, then we get sodium acetate, water and carbon dioxide is formed. Then when sodium carbonate and dilute sulfuric acid is reacted, then dilute sulfuric acid, it forms sodium sulfate, water and carbon dioxide. Okay, please check the reactions. Okay, see, then how is lamp black prepared on a large scale? To prepare lamp black, we need to burn hydrocarbons like kerosene oil containing a large number of carbon and in insufficient supply of air. Okay, there should be insufficient supply of air, and the hydrocarbons should be burned like kerosene, which contains a large amount of carbon. Now these hydrocarbons burn, producing a smoky flame which contains large amounts of carbon. The smoke is allowed to cool when the carbon settles down in the form of fine black powder. Okay, so the hydrocarbons, they burn, forming a smoky flame that contains large number of carbon, and the smoke is allowed to cool when the carbon settles down and it forms a fine black powder. That's our soot. Now, how is the bone charcoal prepared? State the of bone charcoal. See, when first the bones, they are dried in the sun and then crushed to form powder. Okay, this powder is distilled destructively, that is in limited supply of air, distillation is taking place. Then the residue which is left behind after the process is bone ash. Okay, that contains 10% of carbon approximately. Okay, now the carbon present in the bone ash is removed by dissolving it in hydrochloric acid in which the calcium phosphate dissolves, leaving behind the carbon. So bone ash, that contains 10% of carbon, and this bone ash then is dissolved in dilute hydrochloric acid, which will separate out the calcium, which will dissolve the calcium phosphate, okay, leaving behind the carbon. Okay, so bone contains calcium phosphate also, that will get dissolved in the hydrochloric acid, and the carbon will be left behind. The carbon then is filtered out from the solution, and that is the bone charcoal. Okay, the bone charcoal contains calcium phosphate. I told you that mainly it is 10 to 12% of carbon is present in the bone charcoal. Now, how does wood charcoal react with the following: oxygen, steam, and copper oxide? This wood charcoal, that is carbon. Okay, so carbon will combine with the oxygen when it is burning, and around 400 degrees centigrade, it will burn without flame, and that will produce carbon dioxide, and it's an exothermic reaction. Heat will be produced. Second is this carbon dioxide will again come this carbon. Yes, this carbon, wood charcoal, in limited supply of air, if it is there, then it will produce carbon monoxide. Okay. Next is, and when this white hot wood charcoal, if it is used, when it is reacted with steam, then it produces carbon monoxide and hydrogen gas, that is known as water gas. Okay, then copper oxide, when reacted with wood charcoal in presence of heat, it will reduce the copper oxide to copper, and carbon monoxide will be formed. Now state 4 physical properties of wood charcoal. It's a gray, brittle solid, porous in nature. Okay, it's brittle solid which is porous in nature. Its density is 1.5 grams per centimeter cube, but it flows, that means it is heavier than water, but it will float on the surface of water because it is porous. It has large amount of air which is trapped inside the pores. Now on boiling, when we boil the charcoal, what will happen? This air inside the pores, that will escape, and it will become heavier, and the wood charcoal will sink inside the water. Okay. Now it is a bad conductor of heat and electricity. It absorbs gases, liquids and solids, and these gases on or liquids can be released through simple process of heating. Okay. Then state 5 physical properties of graphite. Graphite is a dark gray solid having a metallic luster. It is a dark gray solid, but it has a metallic luster. It shines like a metal. Then it is a soft grease. It is a soft greedy touch. It has a soft greasy touch. That is, if we touch it, it will be we feel that it is slightly oily, and it is soft also. It marks the paper gray. That's why it is used for making pencils, lead pencils. Then its density is 2.25 grams per centimeter cube. It is a good conductor of heat and electricity, and it is insoluble in ordinary solvents. Now, what is graphite? Describe the structure of graphite and how is graphite artificially manufactured. See, graphite is also called as plumbago or black lead. Okay, and it is a naturally occurring form of crystalline carbon. Okay, now the carbon atoms in graphite are arranged in the form of hexagonal rings in flat planes. Okay, they are formed in hexagonal rings in flat planes in such a way that these rings are stacked one above the other. Okay, like we keep boxes, no, one above the other, like that. These rings, the flat, they are stacked one above the other, and each carbon atom is a hexagonal ring attached to 3 other carbon atoms. In the hexagonal ring, 1 carbon atom is attached to 3 carbon atoms in the same plane. The fourth valence electron of each carbon atom remains loose between the hexagonal planes, and the fourth electron of each carbon atom imparts the properties of heat and electricity conductivity to graphite. What happens? As this has a loose carbon atom, that due to that property, that it is a good conductor of heat and electricity. Okay. Then furthermore, loose bonds between the hexagonal crystals enable them to slide, and that's why it's greasy, smooth, slippery, and an excellent lubricant it can be used. Okay, then graphite is prepared artificially by heating powdered coke. If we heat powdered coke mixed with a little amount of sand and ferric oxide, it is in an electric furnace, then we can produce graphite. Okay. And next is state 6 physical properties of diamond. It's naturally occurring solid. Then amongst the diamonds, the black diamonds are the hardest. A pure diamond is colorless, transparent, and brittle solid. A pure diamond is transparent to the X-rays and visible light. Okay, the density of pure diamond is 3.5 grams per centimeter. It is I will say it is a very poor conductor of heat and electricity, and it is insoluble in all solvents. Okay. So I'll stop here. A little amount of question answers are left of this chapter. I'll do it in the next video. Okay. Please go through this. If you have any doubt, please do write in the comment box. Do share with your friends and colleagues so that they can also be benefited from these videos. And do subscribe to get the notification of my next video. Thank you. Thank you for watching and have a good day.